Hello everyone, and welcome to this example recording on the step response of RC circuits. So the question we're going to be looking at reads as follows. For the circuit below, determine Vx for t greater than 0. As we can see, Vx is the voltage over the capacitor, which is a voltage response, which is expected. We can also see that when t is equal to 0, the current source as well as the voltage source is still connected to the capacitor, so this will be a step response of an RC circuit, and given that that will be the response type, we know that the expression for the final voltage the final voltage expression will be V infinity plus V0 minus V infinity e to the negative t over tau, where this is your voltage at time t is equals to infinity, and this is your voltage at time t is equals to 0, and that is your time constant. These are the three things that we need to look for. So let's start off at time t is equals to 0 negative. So what will happen then? The capacitor we know will be an open circuit. The circuit will be open, and we will have the resistor and the current source. That will look like that. This will be 12 ohms, and that will be 2 amps. And we're looking for the voltage plus minus VO. And let's call this A and B. So we can say that VO can be seen as VAB, which is VA minus VB. VA, we can see we start off at 0. There's a 10 ohm resistor here that we've missed out, but it won't make a difference because there's no current flowing through there, so there won't be any voltage drop. So we start off at 0. We increase by 30 to get to positive 30. So VA must be positive 30 volts. What about VB? For us to get VB must give you the voltage at this point, which must be the current times this resistance, because all of this current will go down there. Nothing will go across. So that will be 2 times 12, which is 2 times 12, which gives you 24 volts. So VO will therefore give you 30 minus 24, which gives you 6 volts. Right, so we've got the initial voltage. What about the final voltage? So what happens when time t tends to infinity? So when t tends to infinity, we will have a similar circuit. Only difference now is that we're going to have 2 resistors and the current source. So that will be 30. This will be 5, and this will be 12, and this will be 2. And again, we're going to have that as A and B and plus minus, call this V infinity. So V infinity will give you again VA minus VB. For us to determine VB this time, we're going to say first 12 ohms in parallel with 5 ohms. Let's see what that gives us. So 12 in parallel with 5. That will give us an answer of 3,53 ohms. Alright, so now you will have a circuit that looks identical to that one, where this resistance is now 3,53 ohms. So we can calculate the voltage VB. So we can say VB is going to give you 3,53 multiplied by the current, which is 2, which will give you a value of 7,06 volts. Right, and VA again is going to give us a value of, with this 10 ohm resistor here, it's still going to give us a value of positive 30. So VA is equals to positive 30 volts, such that V infinity will be 30 minus 7,06. And that gives us a value of 22,94 volts. Right, so we've got our V infinity, we've got our V0, we've got our V infinity, we've got our V0, and now we need to get the time constant. All right, when t is greater than 0, we know that the time constant is going to be given by RC. What will the equivalent resistance be when t is greater than 0? So this is the diagram when t is greater than 0. And we need to deactivate your sources. So the current source will become an open circuit, such that you will, and the voltage source will become a short circuit. So you're going to have something that looks as follows, and that will become a open circuit, such that we've got 10 ohms, 5 ohms, and 12 ohms. And we should be able to see that RTH is going to give you 10 plus the parallel combination of 12 and 5, which is going to give you 10 plus 3,53, as we calculated this parallel combination there, which then gives us 13,53 ohms. And the capacitor value is given as 5 farads. So C equivalent is going to be 5 farads. Therefore tau, which is RC, is going to give you 5 times 13,53. So 13.53 times 5, that gives us a value of 67,65. Right, and then our final expression is going to be V as a function of time is going to give you V infinity, which is 22.94 plus V0, which is 24, minus 22.94 e to the negative t over 67.65, and this will be in volts. So this should give you 22.94 plus, so 24 minus 22.94 should give you a final value of 1,06. So that will be plus 1,06 e to the negative t over 67.65 volts, and that's the final voltage expression. Thank you for watching this video and enjoy the course.